Welcome, and thank you for joining me. Tonight, we'll take a slow and fascinating journey through the world of disease and medicine, exploring 100 remarkable facts from the history of epidemics, the human immune system, groundbreaking medical discoveries, and the tiny organisms that have shaped life on Earth for millions of years. Now, dim the lights, get comfortable, and let's begin with our first fascinating disease fact. Smallpox was the first human disease to be eradicated. For thousands of years, smallpox was one of humanity's most feared diseases. Caused by the variola virus, it spread easily from person to person and often left survivors with permanent scars. In the 20th century alone, it is estimated to have caused hundreds of millions of deaths worldwide. Thanks to a coordinated global vaccination campaign led by health organizations and governments, the last naturally occurring case was recorded in Somalia in 1977. In 1980, the World Health Organization officially declared smallpox eradicated, making it the first, and so far only, human disease completely eliminated through vaccination. Not every disease is contagious. When people hear the word disease, they often think of illnesses that spread from one person to another. In reality, many diseases are not contagious at all. Conditions such as diabetes, Alzheimer's disease, osteoporosis, and most forms of cancer cannot be passed between people through everyday contact. Diseases can develop for many different reasons, including genetic changes, immune system disorders, environmental exposures, nutritional deficiencies, or the natural aging process. Understanding this distinction helps explain why medicine includes far more than simply treating infections. Your body is home to trillions of helpful microbes. Although microbes are often associated with disease, the vast majority of them are either harmless or beneficial. Trillions of bacteria, fungi, and other microscopic organisms naturally live on your skin, inside your mouth, and throughout your digestive system. Together they form what scientists call the human microbiome. Many of these organisms help digest food, produce certain vitamins, compete with harmful microbes, and support the immune system. In fact, maintaining a healthy balance of these microorganisms is considered an important part of overall health. Fever is a defense, not a disease. A fever can feel unpleasant, but it is actually one of the body's natural defense mechanisms. When your immune system detects an infection, it may raise your body's temperature slightly. This warmer environment can make it more difficult for some bacteria and viruses to reproduce while helping certain immune cells work more efficiently. Although high fevers sometimes require medical attention, a mild fever often represents the body's normal response to illness rather than the illness itself. It is a sign that your immune system has recognized a potential threat and is responding. Antibiotics only work against bacteria. Antibiotics are among the most important discoveries in modern medicine, but they have one important limitation. They only work against bacterial infections. They do not kill viruses responsible for illnesses like the common cold, influenza, or COVID-19. Using antibiotics when they are not needed can encourage bacteria to develop resistance, making future infections more difficult to treat. Because of this, healthcare professionals recommend taking antibiotics only when they are prescribed for confirmed or strongly suspected bacterial infections. The common cold has hundreds of possible causes. There is no single virus responsible for the common cold. Instead, more than 200 different viruses can produce similar symptoms, with rhinoviruses being the most common. Because there are so many different cold viruses, and they frequently change over time, developing one universal vaccine has proven extremely difficult. Most healthy people recover within a week or two as the immune system gradually clears the infection. This wide variety of viruses explains why people can catch multiple colds throughout their lives. Malaria is caused by a parasite. Unlike many well-known infectious diseases, malaria is not caused by a virus or a bacterium. Instead, it results from microscopic parasites belonging to the genus Plasmodium. These parasites are transmitted primarily through the bites of infected female Anopheles mosquitoes. Once inside the body, they first infect the liver before entering red blood cells, where they continue multiplying. Malaria has affected human populations for thousands of years and remains a significant public health challenge in many tropical and subtropical regions of the world. The same virus causes chickenpox and shingles. Many people think chickenpox and shingles are completely different illnesses, but they are actually caused by the same virus, the varicella-zoster virus. After someone recovers from chickenpox, the virus usually doesn't disappear completely. Instead, it remains inactive inside certain nerve cells, sometimes for decades. Later in life, particularly as people grow older or their immune system becomes weakened, the virus can reactivate and cause shingles, a painful rash that typically affects one side of the body. Vaccines train the immune system before infection happens. Vaccines work by giving the immune system a safe opportunity to recognize a disease-causing organism before encountering the real infection. Depending on the vaccine, this may involve weakened viruses, inactivated viruses, purified proteins, or genetic instructions that allow the body to temporarily produce harmless pieces of a pathogen. In response, the immune system creates antibodies and memory cells that remain prepared for future encounters. This means that if the actual pathogen appears later, the body can often respond much more quickly and effectively. Tuberculosis has been known for thousands of years. Tuberculosis, often called TB, is one of the oldest diseases known to affect humans. Evidence of tuberculosis has been found in ancient Egyptian mummies that are thousands of years old. The disease is caused by the bacterium Mycobacterium tuberculosis and most commonly affects the lungs, although it can also spread to other parts of the body. Today, tuberculosis is both preventable and treatable, yet it continues to affect millions of people worldwide each year, making it an important focus of global public health efforts. Measles is one of the most contagious diseases. Measles is caused by a virus that spreads through tiny droplets released into the air when an infected person coughs, sneezes, or even breathes. The virus can remain in the air or on surfaces for up to 2 hours, making it remarkably easy to spread. Before widespread vaccination, measles infected millions of people every year across the globe. Today, safe and effective vaccines have dramatically reduced cases in many countries, although outbreaks can still occur in communities where vaccination rates fall below recommended levels. The Black Death changed the course of history. During the mid-14th century, Europe experienced one of the deadliest disease outbreaks ever recorded. Known as the Black Death, this pandemic was caused by the bacterium Yersinia pestis, the same organism responsible for plague today. Historians estimate that tens of millions of people died over just a few years, dramatically reducing the population of Europe, Asia, and parts of North Africa. The pandemic reshaped economies, altered labor systems, and influenced politics, religion, and medicine for generations, making it one of history's most significant events. Cholera can spread through contaminated water. Cholera is a bacterial disease that primarily spreads through water or food contaminated with human waste. The bacteria produce a powerful toxin inside the intestines, causing severe diarrhea that can quickly lead to dehydration if left untreated. Throughout history, cholera outbreaks have often occurred in places where clean drinking water and proper sanitation were unavailable. Today, improvements in water treatment, sewage systems, and public health infrastructure have greatly reduced the disease in many parts of the world, although it still affects some regions during humanitarian crises. Rabies is nearly always preventable after exposure. Rabies is a viral disease that affects the brain and nervous system of mammals, including humans. It is most commonly spread through the bite of an infected animal, allowing the virus to enter the body through broken skin. One remarkable feature of rabies is that there is often a delay of weeks or even months before symptoms begin. During this window, prompt medical treatment with vaccines and immune globulin can prevent the disease from developing. This makes rabies one of the few serious viral infections that can often be stopped even after exposure. Leprosy is much less contagious than people once believed. For centuries, leprosy carried enormous social stigma because people believed it spread easily through casual contact. Modern research has shown that this is not the case. The disease, also known as Hansen's disease, is caused by the bacterium Mycobacterium leprae and spreads only through prolonged, close contact over long periods of time. Most people also have natural immunity to the bacterium. Today, leprosy is completely curable with a combination of antibiotics, and early treatment can prevent many of the complications once associated with the disease. The plague still exists today. Although many people associate plague with medieval history, the disease has never completely disappeared. Small numbers of cases are still reported each year in various parts of the world, including regions of Africa, Asia, and the Americas. Like the historical Black Death, modern plague is caused by the bacterium Yersinia pestis, which can be carried by wild rodents and transmitted by fleas. Fortunately, today's understanding of the disease, combined with rapid diagnosis and antibiotic treatment, means that most patients recover when treated early. Hepatitis simply means inflammation of the liver. Many people think hepatitis refers to a single disease, but the word actually describes inflammation of the liver, regardless of its cause. Several different viruses, including hepatitis A, B, C, D, and E, can cause viral hepatitis, but alcohol use, certain medications, autoimmune disorders, and other medical conditions may also inflame the liver, because the liver performs hundreds of essential functions, including filtering blood and processing nutrients. Keeping it healthy is vital for overall well-being. Some forms of hepatitis are preventable through vaccination. Tetanus bacteria are commonly found in soil. The bacteria that cause tetanus are naturally present in soil, dust, and the digestive systems of many animals. They produce spores that can survive in the environment for years before entering the body through cuts or puncture wounds. Once inside, the bacteria release a powerful toxin that interferes with the nerves controlling muscles, causing painful muscle stiffness and spasms. Thanks to routine vaccination, tetanus has become rare in many countries, but booster vaccinations remain important because immunity gradually decreases over time. Some diseases are caused by fungi. While viruses and bacteria receive most of the attention, fungi can also cause disease in humans. Many fungal infections affect the skin, hair, or nails, such as athlete's foot and ringworm, while others can involve the lungs or other organs, particularly in people with weakened immune systems. Fungi differ greatly from both plants and animals and form their own biological kingdom. Although most fungi in nature are harmless, and many are even beneficial, certain species have adapted to live in or on the human body under the right conditions. Disease detection has changed dramatically over time. For much of human history, doctors diagnosed diseases by carefully observing symptoms because they had no way to see the tiny organisms responsible for illness. The invention and improvement of the microscope transformed medicine by allowing scientists to discover bacteria, parasites, and eventually viruses. Today, physicians use advanced laboratory tests, medical imaging, and genetic sequencing to identify diseases with remarkable precision. These technologies help doctors diagnose illnesses earlier, choose more effective treatments, and better understand how diseases spread through populations. Influenza viruses are constantly changing. Influenza, commonly known as the flu, is caused by a group of viruses that are constantly evolving. Small genetic changes occur over time through a process called mutation, allowing new strains to appear each year. Because of these ongoing changes, the immune system may not fully recognize a new strain, even if someone has had the flu before. This is also why seasonal influenza vaccines are updated regularly to match the strains expected to circulate during each flu season as closely as possible. Sepsis is the body's extreme response to infection. Sepsis is not an infection itself, but rather a serious medical condition that occurs when the body's response to an infection becomes overwhelming. Instead of targeting only the harmful microbes, the immune system can begin affecting healthy tissues and organs as well. This widespread inflammatory response may damage the heart, lungs, kidneys, and other vital organs if not treated promptly. Modern medicine recognizes sepsis as a medical emergency, and early diagnosis and treatment have greatly improved survival rates. White blood cells are your body's defenders. Your bloodstream contains several different types of white blood cells, each with a specialized role in protecting your body from disease. Some cells search for bacteria and destroy them, while others produce antibodies that recognize viruses and other foreign invaders. Certain white blood cells can even remember previous infections, allowing your immune system to respond much faster if the same pathogen returns. Together, These cells work continuously, often without you noticing, to keep you healthy every single day. Alzheimer's disease is the most common cause of dementia. Alzheimer's disease is a progressive disorder that gradually affects memory, thinking, and behavior. It is the most common cause of dementia, especially in older adults. Scientists believe the disease is associated with abnormal buildups of proteins in the brain, which interfere with communication between nerve cells over time. Although there is currently no cure, ongoing research has greatly expanded our understanding of the disease, and new treatments continue to focus on slowing its progression and improving quality of life. Parkinson's disease primarily affects movement. Parkinson's disease is a neurological disorder that develops when certain nerve cells in the brain gradually stop producing enough dopamine, a chemical messenger involved in controlling movement. As dopamine levels decrease, people may experience tremors, muscle stiffness, slower movements, and difficulties with balance. The condition usually develops gradually over many years and varies from person to person. While there is currently no cure, medications and therapies can often help people manage symptoms and remain active for many years. Autoimmune diseases occur when the immune system becomes confused. The immune system normally protects the body by identifying harmful bacteria, viruses, and other foreign invaders. In autoimmune diseases, however, the immune system mistakenly attacks healthy tissues instead. More than 80 different autoimmune diseases have been identified, including rheumatoid arthritis, lupus, and type 1 diabetes. Scientists continue to study why this happens, believing that a combination of genetics, environmental factors, and immune system changes may all contribute to the development of these conditions. Antibiotic resistance is a natural process accelerated by human activity. Bacteria have an extraordinary ability to adapt to their surroundings. When antibiotics are used, most bacteria may be eliminated, but a few naturally resistant ones can survive and multiply. Over time, these resistant bacteria become more common, making certain infections harder to treat. This process is known as antibiotic resistance. Careful use of antibiotics, combined with ongoing research into new medicines, helps slow the development of resistance and preserve the effectiveness of existing treatments. Osteoporosis gradually weakens bones. Osteoporosis is a condition that causes bones to become less dense and more fragile over time. Throughout life, the body is constantly breaking down old bone tissue while creating new bone. As people age, this balance can shift, leading to a gradual loss of bone strength. Because osteoporosis develops slowly and often without noticeable symptoms, many people do not realize they have it until they experience a fracture. Regular exercise, adequate calcium, vitamin D, and healthy lifestyle choices all help support strong bones. Asthma causes the airways to narrow. Asthma is a long-term condition that affects the airways carrying air into and out of the lungs. In people with asthma, these airways can become inflamed and more sensitive to triggers such as pollen, dust, cold air, exercise, or respiratory infections. During an asthma flare-up, the muscles surrounding the airways tighten while extra mucus is produced, making breathing more difficult. Although asthma cannot currently be cured, modern treatments help millions of people successfully control their symptoms and live active lives. The human immune system never truly rests. Even while you sleep, your immune system remains active. Specialized cells constantly patrol your bloodstream and tissues, searching for viruses, bacteria, damaged cells, and other potential threats. At the same time, your body repairs tissues, produces new immune cells, and strengthens the memory of previous infections. This continuous activity allows your immune system to respond quickly whenever harmful microorganisms enter the body. Although you rarely notice its work, your immune system is protecting you every hour of every day. The bubonic plague gets its name from swollen lymph nodes. One of the most recognizable forms of plague is known as bubonic plague. Its name comes from the word bubo, which refers to the swollen, painful lymph nodes that often develop during the infection. These swellings usually appear in the groin, armpits, or neck as the immune system responds to the invading bacteria. Although the disease was once associated with devastating pandemics, Modern antibiotics can successfully treat most cases when they are diagnosed early, making plague far less deadly than it was centuries ago. Viruses are among the smallest infectious agents. Viruses are incredibly tiny, much smaller than most bacteria. In fact, thousands of viruses could fit across the width of a single human hair. Unlike living cells, viruses cannot reproduce on their own. Instead, they must enter the cells of a living host and use that cell's machinery to create new copies of themselves. This unique way of reproducing is one reason viral diseases can be difficult to treat, as medicines must target the virus without damaging the body's healthy cells. The liver can repair itself. The liver is one of the few organs in the human body with an extraordinary ability to regenerate. Even after part of the liver has been damaged or surgically removed, the remaining healthy tissue can grow and restore much of its original size and function. This remarkable ability helps the liver recover from certain injuries and illnesses. However, repeated or long-term damage from diseases such as chronic hepatitis or excessive alcohol use can eventually overwhelm its regenerative capacity, leading to permanent scarring known as cirrhosis. Pneumonia is an infection of the lungs. Pneumonia occurs when the tiny air sacs inside the lungs become inflamed and may fill with fluid or pus. This makes it more difficult for oxygen to move from the lungs into the bloodstream. Pneumonia is not caused by a single germ but can result from bacteria, viruses, or fungi. While many healthy people recover completely with appropriate treatment and rest, the illness can be especially serious for infants, older adults, and people whose immune systems are weakened. The immune system can remember past infections. One of the most remarkable features of the human immune system is its ability to remember diseases it has encountered before. After fighting certain infections or responding to a vaccine, specialized memory cells remain in the body for years, and sometimes even for life. If the same pathogen returns, these cells recognize it much more quickly and launch a faster, stronger immune response. This biological memory is the foundation of vaccination and one of the reasons people often develop long-lasting protection against certain diseases. Fungi are more closely related to animals than plants. Although mushrooms grow in forests and mold appears on old food, fungi belong to their own unique kingdom of life. Surprisingly, scientists have discovered that fungi are evolutionarily more closely related to animals than they are to plants. Most fungi play important roles in nature by breaking down dead organic material and recycling nutrients. Only a small number are capable of causing disease in humans, and these infections are usually mild, although some can become serious in people with weakened immune systems. Some diseases can remain silent for years. Not every disease causes noticeable symptoms right away. Certain conditions can develop quietly over months or even years before a person realizes anything is wrong. High blood pressure, chronic hepatitis B or C, osteoporosis, and some forms of cancer may progress without causing obvious discomfort in their early stages. Because of this, regular medical checkups and screening tests can sometimes detect diseases before symptoms appear, allowing treatment to begin earlier and improving long-term outcomes. Mosquitoes are the world's deadliest animals. Despite their tiny size, mosquitoes are responsible for more human deaths each year than any other animal. The danger comes not from the insects themselves, but from the diseases they can carry and transmit while feeding on blood. Different mosquito species spread illnesses such as malaria, dengue fever, yellow fever, Zika virus, and chikungunya. Public health efforts that reduce mosquito populations and prevent mosquito bites have saved countless lives and remain an important part of disease prevention around the world. The discovery of germ theory changed medicine forever. For much of history, people had little understanding of what caused disease. During the 19th century, scientists developed what became known as the germ theory of disease, demonstrating that many illnesses are caused by microscopic organisms such as bacteria and viruses. This breakthrough transformed medicine by encouraging hand washing, sterilization of surgical instruments, cleaner hospitals, safer food preparation, and the development of vaccines and antibiotics. Germ theory remains one of the most important scientific discoveries in the history of healthcare. Sleep helps strengthen your immune system. While you sleep, your body performs many important maintenance tasks, including supporting the immune system. During restful sleep, the body produces and releases proteins called cytokines, some of which help coordinate immune responses during infection or inflammation. Sleep also allows immune cells to communicate more effectively and strengthens the body's memory of previous infections after vaccination. Although sleep alone cannot prevent disease, consistently getting enough quality rest plays an important role in maintaining overall health and supporting your body's natural defenses. Diabetes has been recognized for thousands of years. Diabetes is one of the oldest diseases described in medical history. Ancient physicians observed that some people experienced excessive thirst, frequent urination, and unexplained weight loss. Today, scientists understand that diabetes affects how the body regulates blood sugar or glucose, which serves as an important source of energy for cells. There are several forms of diabetes, with type 1 resulting from an autoimmune process and type 2 involving insulin resistance. Modern treatments and monitoring have greatly improved the lives of millions of people living with the condition. Your skin is the body's first line of defense. The skin is much more than a protective covering. It is one of the body's most important defenses against disease. Acting as a physical barrier, healthy skin prevents countless bacteria, viruses, fungi, and other microorganisms from entering the body each day. It also contains immune cells that quickly recognize and respond to invading microbes. Even the slightly acidic surface of the skin helps discourage the growth of many harmful organisms, making your skin an essential part of the immune system. Some bacteria are essential for good health. Although bacteria are often associated with disease, only a small percentage are harmful to humans. In fact, your body depends on beneficial bacteria for many important functions. These helpful microbes assist with digestion, produce certain vitamins, support the immune system, and compete with harmful bacteria for space and nutrients. Scientists continue to discover new ways that the human microbiome influences overall health, demonstrating that many bacteria are valuable partners rather than dangerous invaders. Scurvy was once a major threat to sailors. For centuries, sailors embarking on long ocean voyages often developed a mysterious disease that caused weakness, bleeding gums, joint pain, and poor wound healing. This condition, known as scurvy, was eventually discovered to result from a lack of vitamin C. Fresh fruits and vegetables contain abundant vitamin C, but these foods were difficult to preserve during months at sea. Once citrus fruits became a regular part of sailors' diets, scurvy became far less common and maritime health improved dramatically. Cancer begins when cells lose normal growth control. Every day, billions of cells in your body divide, grow, and eventually die as part of a carefully regulated process. Cancer develops when certain cells acquire genetic changes that allow them to ignore these normal controls. Instead of stopping when they should, the abnormal cells continue multiplying, forming tumors or spreading to other parts of the body. Scientists now know that cancer is not a single disease, but a collection of more than 100 different diseases, each with its own characteristics and treatments. The lymphatic system helps protect against disease. Running alongside your blood vessels is another important network called the lymphatic system. It carries a clear fluid known as lymph, which contains white blood cells that help fight infection. Throughout this network are hundreds of small structures called lymph nodes, where immune cells gather to identify and respond to harmful microbes. When you're sick, these lymph nodes may temporarily swell as they work harder to filter pathogens and coordinate the body's immune response. Polio once caused worldwide fear. Before effective vaccines became widely available, polio was one of the most feared childhood diseases. Caused by the polio virus, it usually produced mild symptoms, but in some cases it attacked the nervous system, leading to muscle weakness or paralysis. During major outbreaks in the 20th century, swimming pools, schools, and public gathering places were sometimes closed in an effort to reduce transmission. Global vaccination campaigns have since reduced polio cases by more than 99%, bringing the disease close to worldwide eradication. Some diseases are spread by tiny ticks. Ticks are small arachnids that feed on the blood of animals and humans. While most tick bites are harmless, Some ticks can carry bacteria, viruses, or parasites capable of causing disease. One of the best-known examples is Lyme disease, which is caused by the bacterium Borrelia burgdorferi in many regions. Because ticks often live in grassy or wooded areas, checking your skin after spending time outdoors can help reduce the risk of tick-borne illnesses. The body constantly replaces its blood cells. Your blood may seem permanent, but its cells are constantly being replaced. Every second, your bone marrow produces millions of new red blood cells, white blood cells, and platelets to replace older ones that have worn out. Red blood cells typically live for about 120 days before being recycled by the body. This continuous renewal helps ensure that oxygen continues reaching your tissues, while your immune system remains prepared to respond to infections whenever they arise. Medical imaging has revolutionized disease detection. For thousands of years, doctors could only examine the outside of the human body when searching for signs of disease. Today, technologies such as X-rays, CT scans, MRI scans, and ultrasound allow physicians to see inside the body without surgery. These imaging techniques help detect broken bones, tumors, infections, heart disease, and countless other conditions at much earlier stages than was once possible. As medical imaging continues to improve, doctors are able to diagnose diseases with greater speed, accuracy, and detail than ever before. The kidneys filter your blood around the clock. Your kidneys work continuously to keep your body in balance. Every day, they filter roughly 180 liters of fluid from your bloodstream, removing waste products while carefully returning most of the water and useful substances back into circulation. In addition to producing urine, the kidneys help regulate blood pressure, maintain healthy electrolyte levels, and produce hormones that support red blood cell production. Diseases affecting the kidneys can gradually reduce their ability to perform these essential tasks, sometimes without causing noticeable symptoms in the early stages. Tuberculosis can remain dormant for years. Not everyone infected with the bacterium that causes tuberculosis becomes sick right away. In many people, the immune system successfully contains the bacteria, preventing them from causing active disease. This is known as latent tuberculosis infection. During this stage, a person has no symptoms and cannot spread the disease to others. However, if the immune system later becomes weakened, the bacteria can become active and begin causing illness, sometimes many years after the initial infection. Viruses have been infecting life for millions of years. Viruses are not a recent part of Earth's history. Scientists believe they have existed for hundreds of millions, and possibly billions, of years, evolving alongside the organisms they infect. Today, viruses can infect almost every form of life, including animals, plants, fungi, bacteria, and even other viruses in rare cases. Although some viruses cause disease, many exist in nature without causing noticeable harm, making them one of the most widespread biological entities on the planet. The human body can develop allergies at any age. Many people associate allergies with childhood, but they can develop at almost any point in life. An allergy occurs when the immune system mistakenly identifies a normally harmless substance, such as pollen, peanuts, or pet dander, as a threat. During future encounters, the immune system reacts by releasing chemicals like histamine, producing symptoms such as sneezing, itching, or swelling. Scientists are still studying why allergies appear in some people and not others, but both genetic and environmental factors seem to play important roles. Cholera helped transform public health. One of the greatest breakthroughs in public health came during the 19th century, when repeated cholera outbreaks prompted scientists to investigate how diseases spread. During a famous outbreak in London in 1854, physician John Snow carefully mapped cases of illness and discovered that many patients had obtained their drinking water from the same public pump. His investigation provided powerful evidence that contaminated water was spreading the disease. This discovery helped shape modern sanitation systems and greatly improved the safety of drinking water in cities around the world. Some diseases can jump between animals and humans. Diseases that spread between animals and humans are known as zoonotic diseases. Scientists estimate that a large proportion of newly emerging infectious diseases in humans originally came from animals. Examples include rabies, avian influenza, Ebola, and several coronaviruses. Because humans and animals often share environments, understanding animal health has become an important part of protecting human health as well. This approach, known as One Health, recognizes that the health of people, animals, and the environment are closely connected. The spleen plays an important role in fighting disease. Although many people rarely think about the spleen, it performs several important functions within the immune system. Located in the upper left side of the abdomen, the spleen filters blood, removes old or damaged red blood cells, and helps detect bacteria and other harmful microorganisms. It also stores certain immune cells that can respond rapidly during infection. While people can live without a spleen, they become more vulnerable to certain bacterial infections and may require additional vaccinations for protection. Ringworm isn't caused by a worm. Despite its unusual name, ringworm has nothing to do with worms. It is actually a fungal infection that affects the skin, scalp, or nails. The name comes from the circular, ring-shaped rash that often develops as the fungus spreads outward from the center of the infection. Ringworm is usually treated with antifungal medications and often clears completely with proper treatment. Because fungi thrive in warm, moist environments, the infection can spread more easily in places such as locker rooms and swimming facilities. High blood pressure often has no warning signs. High blood pressure, also known as hypertension, is sometimes called the silent killer because it usually develops without causing noticeable symptoms. A person may feel perfectly healthy while increased pressure gradually places extra strain on the heart, blood vessels, kidneys, and brain. Over many years, untreated hypertension can increase the risk of heart attacks, strokes, kidney disease, and other serious health problems. Regular blood pressure checks are important because they can detect the condition long before symptoms appear. Disease research continues to change every year. Medical science is constantly expanding our understanding of disease. Every year, researchers identify new genes linked to illness, develop more accurate diagnostic tests, improve vaccines, and create innovative treatments for conditions that were once considered untreatable. Advances in fields such as genetics, artificial intelligence, and medical imaging are helping doctors detect diseases earlier and personalize treatments for individual patients. Although many diseases still present significant challenges, ongoing scientific research continues to improve healthcare and deepen our understanding of the human body. The human body produces millions of new immune cells every day. Your immune system is constantly renewing itself. Deep inside your bones, the bone marrow produces millions of new white blood cells every day to replace older cells and prepare for future infections. Different types of immune cells have different jobs. Some destroy bacteria, others attack virus-infected cells, while still others coordinate the body's overall immune response. This continuous production ensures that your body is always prepared to recognize and respond to potential threats, even though most of this activity happens without you ever noticing. Yellow fever shaped the history of cities and nations. Yellow fever is a viral disease spread by mosquitoes that has influenced history in remarkable ways. During the 18th and 19th centuries, repeated outbreaks affected major cities in the Americas, Europe, and Africa. The disease sometimes halted trade, disrupted military campaigns, and even delayed large construction projects. Scientists eventually discovered that mosquitoes were responsible for spreading the virus, leading to improved mosquito control efforts. Today, an effective vaccine provides long-lasting protection against yellow fever in many parts of the world. The appendix may play a role in the immune system. For many years, the appendix was considered a useless organ with no important function. Modern research has suggested that it may actually serve as a small storage site for beneficial bacteria that normally live in the intestines. It also contains immune tissue that appears to participate in the development of the body's defenses during early life. Although people can live perfectly healthy lives without an appendix, scientists continue studying its possible role in maintaining a healthy gut microbiome. Fungi can be both helpful and harmful. The fungal kingdom includes an enormous variety of organisms, ranging from tiny yeasts to giant mushrooms growing in forests. Most fungi are incredibly beneficial, helping break down dead plants and animals so nutrients can be recycled back into the environment. Humans also rely on fungi to make foods like bread and certain cheeses, as well as medicines such as penicillin. Only a relatively small number of fungal species are capable of causing disease in humans, and many of these mainly affect people with weakened immune systems. The Black Death was not the first plague pandemic. Although the Black Death is the most famous plague outbreak in history, it was not the first. Historians believe the earliest major plague pandemic began during the reign of the Byzantine Emperor Justinian in the 6th century. Known as the Plague of Justinian, it spread throughout parts of Europe, North Africa, and the Middle East, causing widespread illness and death. Centuries later, the Black Death became the second Great Plague pandemic, demonstrating how infectious diseases have repeatedly shaped the course of human civilization. Your nose helps protect you from disease. Every breath you take passes through a remarkable filtering system inside your nose. Tiny hairs called cilia, along with a layer of sticky mucus, trap dust, pollen, bacteria, and other microscopic particles before they can travel deeper into the lungs. The cilia then slowly move this mucus toward the throat, where it is swallowed and safely destroyed by stomach acid. This simple but effective defense system works continuously, helping reduce the number of harmful microbes that reach your respiratory system. Some viruses can remain hidden inside the body. Certain viruses have developed the remarkable ability to remain dormant inside the body long after the initial infection has ended. Instead of being completely eliminated, these viruses hide inside specific cells where the immune system has difficulty detecting them. They may remain inactive for years or even decades before becoming active again under certain conditions, such as aging or changes in the immune system. The viruses responsible for chickenpox and cold sores are well-known examples of this unusual survival strategy. Vitamin deficiencies can cause serious diseases. Long before scientists discovered vitamins, people suffered from diseases caused by missing essential nutrients in their diets. A lack of vitamin C causes scurvy, vitamin D deficiency can lead to rickets, and insufficient vitamin B1 may result in beriberi. These conditions became much less common after researchers identified the importance of vitamins during the early 20th century. Today, balanced diets and food fortification programs help prevent many vitamin deficiency diseases that were once widespread around the world. Your body is constantly searching for abnormal cells. The immune system does much more than fight infections. Every day, specialized immune cells patrol the body looking for damaged, infected, or abnormal cells that could potentially become harmful. Many abnormal cells are identified and removed before they ever cause noticeable problems. This continuous surveillance is one reason scientists often describe the immune system as both a defense against infectious diseases and an important protector against certain other diseases as well. Researchers continue to study this process to develop new treatments for a variety of illnesses. Modern medicine can identify thousands of diseases. Centuries ago, physicians recognized only a limited number of diseases based on visible symptoms. Today, advances in medical science have allowed doctors to identify thousands of distinct diseases and medical conditions, each with its own causes, symptoms, and treatments. Sophisticated laboratory tests, genetic analysis, and advanced imaging technologies have made diagnosis more accurate than ever before. As scientific knowledge continues to grow, researchers regularly discover new diseases, improve classification systems, and develop better ways to understand the complex conditions that affect human health. The stomach uses powerful acid to destroy germs. Your stomach contains hydrochloric acid that is strong enough to break down food and destroy many of the bacteria and viruses that enter your body with each meal. Despite its strength, the stomach usually protects itself with a thick layer of mucus that prevents the acid from damaging its own tissues. While some microorganisms are able to survive this harsh environment, many are eliminated before they can reach the intestines. This makes the stomach one of the body's earliest defenses against foodborne disease. Typhoid fever once spread through many growing cities. Before modern sanitation systems became common, typhoid fever was a frequent cause of illness in crowded cities around the world. The disease is caused by the bacterium Salmonella typhi and spreads through contaminated food or drinking water. During the 19th and early 20th centuries, improvements in clean water supplies, sewage systems, and food safety dramatically reduced the number of cases in many countries. Today, typhoid fever remains most common in regions where access to safe drinking water is still limited. Some bacteria can form protective spores. Certain bacteria have developed an extraordinary survival strategy by forming structures known as spores. When environmental conditions become harsh, these bacteria surround themselves with a tough protective coating that allows them to survive heat, dryness, chemicals, and even years without nutrients. Once conditions improve, the spores can become active bacteria again. The bacteria responsible for tetanus and anthrax are among the best-known examples of organisms capable of producing these remarkably durable survival structures. The lungs are exposed to thousands of liters of air every day. An average adult breathes around 20,000 times each day, bringing thousands of liters of air into the lungs. Along with oxygen, every breath contains tiny particles such as dust, pollen, bacteria, fungal spores, and other microscopic material. Fortunately, the respiratory system has several layers of protection, including mucus, tiny hair-like cilia, coughing, and specialized immune cells that help trap and remove unwanted particles before they can cause disease. These defenses work continuously without requiring any conscious effort. Syphilis has challenged doctors for centuries. Syphilis is a bacterial disease that has been recognized for more than 500 years. Before effective antibiotics were discovered, the illness could progress through several stages over many years, affecting the skin, nervous system, heart, and other organs. Because its symptoms often resemble those of many other conditions, syphilis was historically known as the Great Imitator. Today, the disease can usually be diagnosed through laboratory testing and successfully treated with appropriate antibiotics when detected early. Your bone marrow is a blood cell factory. Hidden inside many of your bones is a soft tissue called bone marrow, where billions of new blood cells are produced every day. Red blood cells carry oxygen throughout the body, white blood cells help fight infection, and platelets assist with blood clotting after injuries. Stem cells within the bone marrow continually divide to replace older blood cells as they wear out. This constant production ensures that your circulatory and immune systems remain healthy and ready to perform their essential functions. Dengue fever is spread by daytime mosquitoes. Unlike many mosquito species that are most active after sunset, the mosquitoes that spread dengue fever usually bite during the daytime, particularly in the early morning and late afternoon. Dengue is caused by a virus and is found mainly in tropical and subtropical regions around the world. Most people recover completely, although some infections can become more severe. Public health efforts focus on reducing mosquito breeding sites and limiting contact between mosquitoes and people to help reduce transmission. The immune system learns throughout your life. Your immune system is not exactly the same throughout your entire lifetime. From infancy onward, it continuously gains experience by encountering new microbes and responding to vaccinations. Each successful encounter teaches the immune system to recognize familiar pathogens more efficiently in the future. This growing collection of immune memories allows your body to respond more rapidly to many infections it has already seen before, making your defenses stronger and more refined as you age. Heart disease refers to many different conditions. The term heart disease does not describe a single illness, but rather a group of conditions that affect the heart and blood vessels. These include coronary artery disease, heart failure, irregular heart rhythms, heart valve disorders, and several inherited conditions. Although these diseases have different causes and treatments, they all involve changes in the structure or function of the heart. Advances in medical research, medications, surgery, and lifestyle interventions have greatly improved outcomes for many people living with heart disease. Scientists continue discovering new viruses. Although thousands of viruses have already been identified, scientists believe they have discovered only a tiny fraction of the viruses that exist in nature. New viruses are regularly found in wildlife, oceans, soil, and even within the human body. Advances in genetic sequencing have made it possible to identify viruses that cannot easily be grown in laboratories. Studying these newly discovered viruses helps researchers better understand how viruses evolve, interact with their hosts, and occasionally emerge as causes of disease in humans or animals. The first vaccines were developed more than 200 years ago. The idea of vaccination has existed for centuries, but the first widely recognized vaccine was developed in 1796 by the English physician Edward Jenner. He observed that milkmaids who had previously been infected with the relatively mild disease cowpox rarely became ill with smallpox. Using this observation, Jenner developed a method that safely prepared the immune system to fight smallpox. His work laid the foundation for modern vaccination, which has since become one of the most successful public health achievements in human history. Scarlet fever was once one of childhood's most feared diseases. Before the discovery of antibiotics, scarlet fever caused frequent outbreaks among children in many parts of the world. The disease is caused by certain strains of Streptococcus bacteria that produce a toxin responsible for the illness's characteristic red rash. During the 19th century, scarlet fever claimed thousands of lives and worried families whenever outbreaks appeared. Today, the disease can usually be treated effectively with antibiotics, and serious complications have become much less common than they once were. Every cut triggers an immune response. Even a small paper cut sets off an impressive chain of events inside your body. Within moments, platelets gather to form a clot and stop the bleeding. White blood cells quickly move toward the injured area to destroy bacteria that may have entered through the wound. At the same time, specialized cells begin repairing damaged tissue by producing new skin and blood vessels. Most of this complex healing process happens automatically, allowing even small injuries to recover with very little conscious effort. The world once feared polio every summer. Before vaccines became available, polio outbreaks often increased during the warmer months of the year. Parents worried about allowing children to swim in public pools, attend summer camps, or gather in large groups because scientists had not yet fully understood how the virus spread. Hospitals filled with patients experiencing paralysis, and some required large breathing machines called iron lungs to help them breathe. Thanks to global vaccination efforts, scenes like these have become increasingly rare, and polio is now close to being eradicated worldwide. Your eyes have their own immune protection. The eyes are constantly exposed to dust, bacteria, and other particles in the environment, yet infections are relatively uncommon thanks to several natural defense systems. Tears do much more than keep the eyes moist. They also contain enzymes and antibodies that help destroy certain bacteria. Blinking regularly washes away debris while spreading fresh tears across the eye's surface. Together, these simple actions help protect one of the body's most delicate organs from infection throughout the day. Inflammation is part of the healing process. When you twist an ankle or develop an infection, the affected area often becomes red, warm, swollen, and sometimes painful. These changes are signs of inflammation, a natural response that helps the body begin repairing damaged tissue and fighting harmful microorganisms. During inflammation, blood flow to the area increases, bringing immune cells and nutrients needed for healing. Although excessive or long-lasting inflammation can contribute to disease, short-term inflammation is an important part of the body's normal defense and recovery process. Some diseases are named after the scientists who studied them. Throughout medical history, many diseases have been named after physicians or researchers who first described them or helped improve scientific understanding of the condition. Examples include Parkinson's disease, Alzheimer's disease, and Hodgkin lymphoma. In recent years, however, scientists have increasingly preferred names that describe the disease itself rather than honoring individuals. This approach helps make medical terminology clearer and reduces confusion across different languages and cultures. The human body is constantly repairing DNA. Every day, the DNA inside your cells experiences thousands of tiny changes caused by normal metabolism, sunlight, and other environmental factors. Fortunately, your cells contain specialized repair systems that constantly search for damaged sections of DNA and fix many of these errors before they can cause problems. These repair mechanisms work around the clock and are essential for maintaining healthy tissues throughout your life. When DNA repair systems fail, the risk of certain diseases, including some cancers, can increase. Medical quarantine has been used for centuries. Long before scientists understood bacteria and viruses, communities noticed that separating sick individuals could sometimes slow the spread of disease. During the 14th century, ships arriving in the city of Venice were often required to wait for 40 days before passengers could disembark if disease was suspected. This period became known as a quarantino, from the Italian word for 40, eventually giving us the modern term quarantine. Today, quarantine remains one of several public health tools used to reduce the spread of certain infectious diseases. The story of disease is also the story of human progress. The history of disease is closely connected to the history of civilization itself. Throughout thousands of years, outbreaks have influenced wars, trade, exploration, scientific discoveries, and the development of modern healthcare. At the same time, each challenge has inspired new advances in medicine, from sanitation and vaccines to antibiotics, medical imaging, and genetic research. Although diseases continue to evolve, so does humanity's understanding of them, making the study of disease one of the most fascinating and continually advancing fields of science. The word influenza has an unusual origin. The word influenza comes from an Italian term meaning influence. During the Middle Ages, many people believed that outbreaks of disease were influenced by the positions of the stars and planets. Although modern science has shown that influenza is caused by viruses rather than celestial events, the name remained. Today, influenza refers to a group of viruses that infect the respiratory system and circulate around the world in seasonal outbreaks each year. Your tonsils help defend against infection. Located at the back of your throat, the tonsils are small collections of immune tissue that act as one of the body's first lines of defense. They help detect bacteria and viruses entering through the mouth or nose and contain immune cells that respond to these potential threats. The tonsils are especially active during childhood as the immune system continues to develop. Although they can become infected themselves, people can still live healthy lives if their tonsils are removed. Viruses outnumber every other biological entity. Viruses are the most abundant biological entities on Earth. Scientists estimate that there are roughly 10 superscript 3 superscript 1 viruses across the planet, a number so enormous that it is difficult to imagine. They exist in the oceans, soil, the atmosphere, and inside nearly every living organism. In just a single teaspoon of seawater, there may be millions of viruses. While only a tiny fraction infect humans, viruses play major roles in ecosystems by influencing populations of bacteria, plants, and animals. The discovery of penicillin changed medicine forever. In 1928, Scottish scientist Alexander Fleming noticed that a mold growing in one of his laboratory dishes had killed the surrounding bacteria. The mold produced a substance that became known as penicillin, the world's first widely used antibiotic. Before antibiotics, even minor cuts or common bacterial infections could become life-threatening. The introduction of penicillin during the 1940s transformed medicine and has since saved countless millions of lives by making many bacterial diseases treatable for the first time. Your body raises its temperature for a reason. When you develop a fever, your brain is intentionally increasing your body's temperature as part of the immune response. Certain immune cells release chemical messengers that signal the brain to raise its internal thermostat. A slightly higher body temperature can slow the growth of some disease-causing microbes while helping immune cells work more efficiently. Although fevers can be uncomfortable, they are often a sign that your body's natural defense systems are actively responding to an infection. Some parasites have incredibly complex life cycles. Unlike many bacteria and viruses, some parasites pass through several completely different stages during their lives. The malaria parasite, for example, spends part of its life inside mosquitoes and another part inside humans. Other parasites may require 2 or even 3 different animal hosts before reaching adulthood. These complex life cycles have evolved over millions of years and allow parasites to spread efficiently through different environments while increasing their chances of survival. Hospitals became much safer after hand washing was introduced. During the mid-19th century, Hungarian physician Ignaz Semmelweis noticed that doctors who washed their hands before delivering babies had far fewer patients dying from infection. At the time, many people did not believe invisible organisms could spread disease, so his ideas were initially dismissed. Years later, the development of germ theory confirmed that hand-washing significantly reduces the spread of harmful bacteria. Today, proper hand hygiene remains one of the simplest and most effective ways to prevent infections in hospitals around the world. Your body contains hundreds of different cell types. The human body is made up of more than 200 different kinds of cells, each designed for a specific purpose. Red blood cells transport oxygen, nerve cells carry electrical signals, muscle cells generate movement, and immune cells defend against disease. Every organ depends on these specialized cells working together in remarkable coordination. Many diseases develop when one particular type of cell becomes damaged, stops functioning properly, or begins growing in an uncontrolled way. Some diseases have almost disappeared. Advances in medicine and public health have caused several once common diseases to become extremely rare in many parts of the world. Improvements in vaccination, clean drinking water, sanitation, nutrition, and antibiotics have dramatically reduced illnesses that once affected millions of people every year. Diseases such as smallpox have been eradicated completely, while others like polio and guinea worm disease are now found in only a handful of locations. These achievements demonstrate the long-term impact of global public health efforts. Medical science is always evolving. Our understanding of disease is constantly changing as researchers make new discoveries. Conditions that were once mysterious are now understood at the genetic and molecular level, while entirely new diseases continue to be identified. Every year, scientists publish thousands of studies exploring better ways to diagnose, prevent, and treat illness. This ongoing research means that medicine is never truly finished. Each discovery builds upon previous knowledge, gradually improving healthcare for future generations around the world.